at any moment, if you don't understand my terrible French accent, or if you cannot read the screen, raise your hand, cry aloud and say, Damien, stop! And we'll try to keep, okay? So the slide will be available, they are already online. They are open source, so if you want to reuse them, to give the talk, or whatever, take it, it's for free. So who am I, Damien? This is where you can find me on the internet. And if you have any question about this, my job and everything, we'll discuss that after the pizza or during the pizza. Just a word about the company I'm working for, Contain House. So that is a tiny startup that started in France 4 years ago. And that company builds traffic, but not only. We have now 4 products. Enterprise edition, we recently released a service mesh for Kubernetes environments. And we also have a Go dynamic interpreter and more products to come. And basically, our money is made on selling services and support for people using traffic or our products. We are 30 people. We are international wide remote. Okay, it's a shop with a Go developer, but I mean, we are growing, so we don't know what the future will be done with. Again, any question during the pizza? Okay, ready? I have everyone? Go. So first step, what problem do we want to solve with traffic? Because I can give you the product saying that's the best product ever and blah, blah, blah. That's not the goal. I want to underline what problem we want to solve. So it will give you an idea of the context. So you will be able to decide if it's a good tool for your context or if another tool fits your needs better, which is really important because this is our job as software engineers, right? So I don't say that's the best product ever. I said that that product is good in certain cases and is not on other cases. Obviously, I will focus on the good cases. That's the game, right? So, history, you all know that history, you know, with the punched card, and then COBOL, and then C and Java for years, and enterprise system bus, and then the SOAP web services, whatever, until microservices, the new golden bullets. And so, yeah, a word about microservices. Everyone's 5 years ago, it was the new Graal. Like everyone should do that. I don't know why, but yeah, okay, do microservices. So the premise was, oh, you will have better platforms, you can deliver faster to your customer and blah and blah. Okay, you know the history of IT, it's always the same cycles. So what happened when everyone went doing microservices? You know what happened, especially if you have a finger on the production, right? It solved problems that it was meant for. This is a good thing, but it creates new problem because it's not magical. The complexity won't fly away with a snap, right? So in the context of microservices, there are new challenges to solve. That's what I want to say. And one of these challenges is when you have a request that has to reach one of your web application or application, the main problem we wanted to solve was, where is my service? You know, in that Kubernetes cluster with tons of nodes and container popping everywhere, how to locate the right target for sending my request. That's the problem we want to solve. We are not inventing something, and we are not the first trying to solve that problem, and we won't be the last. They already have tools since years in that area, especially since the past 6 years between the configuration system, all the container magical stuff, all the, I don't know if you had done some Java with the Netflix library a few years ago, with service discovery or all the HashiCorp tools. There are tons of tools that could help you solving that problem. But the 3 persons that started the traffic project 4 years ago, they all stumbled on one problem with these tools. Writing the configuration file, especially in YAML sometimes. I don't say I hate YAML, I just say be careful with indentation, right? Okay? So if you have a ruler, everything is fine, you can do Kubernetes, okay? We should ask the Kubernetes certification system to give you a ruler as a gift, right? That could be a great idea for the next KubeCon, right? So the idea behind traffic was trying to avoid writing configuration file. So you all know how it ends. You still have to write configuration file, but less. The goal is here. We want to have a tools that will gather the information dynamically and automatically on your system, so you have less and less configuration to manage. It's like removing line of code. It's always a good thing. That is the initial goal of traffic. Sounds good? No question? My accent is not that terrible? Perfect. So say hello to traffic, which is an edge proxy, reverse proxy, server, router, whatever you want. It's edge. The keyword is edge. It's here to solve requests that come from outside your platform and will route these requests inside your platform to the right service. This is what traffic does. Traffic does not route requests from one of your service to another service. We don't do that with traffic. Okay? We often talk about north-south, but in that diagram it does not make sense, while the east-west is something done by other tools. Okay, so the right tool for the right job. We are like Nginx or HA proxy or Kong. We are on the edge of your platform. Okay? So one word about the project in itself. So it's an MIT license. You can find it on GitHub. It's written in Golang. So can you raise your hand if you never written or read any Go lines? Okay, so one person. So Golang is a low-level language created by Google, released in 2009, if I'm not wrong. I'm not sure about the dates. Okay, so that's Go. Why Go is just that it's high level enough to have a big amount of libraries, a vibrant community, so we can connect to Kubernetes, Docker, Rancher, whatever systems. And it's also low level enough without being, it's not Rust, it's not C, but it's low level enough to handle network requests correctly and provide good performance or a good trade-off between performance and resource usage. That's why Go. Because we could have done in C, like in Nginx, in Rust, like Sozu. No, we did that in Go. That's quite popular. It's not Docker, it's not Kubernetes, right? But still, we have some numbers. So we have at least people that download. Maybe it's a script that's downloaded 900 billion times, whatever. And currently, we are on version 1.7. That's the latest stable branch. That's my word about the project. So now the life of the project, we have one big milestone this year. It will be the version 2.0. The first time in 3.5 years where we're gonna break things, because it will be a major version. That was one of the most important thing. You can take the configuration of traffic 1.1 from 2015, you put it on the latest 1.7, it works. You might have tons of warning about depreciation, but it still works with the same behavior. So I can let you imagine that we are packing and queuing the changes that we wanted to do on the core, and we have rewritten almost everything. Okay? But rewriting a software, I mean, it does not make sense. We have done that version because we want to bring a bunch of new features. So first, a revamped documentation. I don't know if you already tried the documentation of the version 1.7. It's a mess. Being honest. No, it has been written when it was tiny and it never scaled as fast as the software. So we had to do a big job and we are still working hard on that with migration guides, startup guides, user guides. So if you are interested to contribute, you are welcome because we really need help on that. That's the most complicated part for me. We have clarified concept, that's something that we'll cover. We have changed the rule for routing. We had a syntax that was sometimes tricky for people coming from Nginx or Apache or HA proxy. The goal of our new expressive routing syntax rule is to describe the routing. You don't route only per VEOST or per path. You can route per cookies or combination. You can do really smart stuff like that domain and that path, or that domain or that cookie. You can implement a lot of scenarios, so you can really do complex stuff. We introduced middlewares, so this will be the next major step. It means everyone will be able to write in Golang some pieces of software, and you can chain middleware that will transform your request. Like one step authenticates to something else, I don't know, replace something on the header, and you can chain and create logical changes on your request. So you can build your own API gateway with some business of yours. TCP support. So we were only layer 7, now we go to the layer transport at layer 4, and UDP is upcoming. And we change a lot of things around TLS, Let's Encrypt, and everything. So just a word about the quick concept, then I show you code and then demo. Sounds good? No question? Still clear? Let's go. No one is sleeping, good. So it's an edge router. Just as a reminder, you have requests that enter your platform through traffic, and then traffic contact your backend service, sending this request, and then it forward back the response from the service, or apply specific behaviors. Okay? The first value of traffic over Nginx or HA proxy in general, because we all know that in specific there are ways to achieve this, traffic is built at core to dynamically watch what we call a provider. You can have different providers. By provider, we mean application provider or services provider. Like you have a Docker engine. Docker, when you create a service, use labels, knows which port is exported, has IPs, names for containers, images. So traffic is able to watch for a single Docker engine and automatically deduce the routing rules based on the labels, the exposed port, etc. Same for Kubernetes. So you can see that as a Kubernetes ingress, but also for Docker Swarm, for Mesosphere, for Marathon, for Consul services, for Azure Service Fabric, and whatever combination of this provider. So you could have different platforms behind. The idea is based on the fact that the developer team in charge of Service 1 already knows since the beginning of the project that this application should be reachable on a set of domain names or paths. So the idea is to say that information is known by the development team, and most of the time when they deploy the application, the information is stored inside a container. So instead of opening a ticket to the sysadmin system that have very big quantity of stuff to do that are more valuable, why not having the tool that will retrieve that information so you don't bother your admin with a few labels or a deployment? And if your service is updated or removed, automatically it will stop routing requests or do whatever complex behavior you want. That's the idea and the value added that we try to put on that proxy. So internally, here you have the traffic proxy. Just a few words about the objects inside. Requests come from into entry points. So these are our pure traffic concept. This is the naming we put inside traffic. So on the configuration file that you still have to write, sorry. Entry points. Routers are, as their name implies, responsible for routing the requests and eventually apply middlewares. And finally, services, which is the representation of the backend services. So this is where the load balancing or canary system or mirroring traffic, whatever could happen. The idea of traffic is that this and this you don't have to configure. And this you have to. That's the idea. So entry point, the first thing that you have to manually configure, is basically saying to traffic, listen on that couple of IP and port. And that's all. So in fact, you have to configure some more advanced stuff. Like if you want to resolve and generate certificate to Let's Encrypt, you have to create an account or at least describe it on the configuration. You need an email, you need a few configuration elements. Or if you provide your own certificates, you also have to at least point them to traffic. This is what the entry points are for. Then the routers. So when your request goes through an entry point, then by default, all routers get the request and try to check if that request following simple rules have to be handled by them or by another. So there is a list of priority. And obviously you can restrict some routers to some entry point if you want to avoid too much muxing traffic. So you have the routers, and they are composed of rules, like every request with the host API domain, that means at HTTP, or every request with the host SNI, if you have TCP level routing with a TLS layer 7 application, And finally, you have the middlewares that will do changes or actions on the request, like forward authentication or just apply authentication, rewrite the request, or whatever you want to do. Finally, oh, I forgot the middleware. Okay, I don't want to spend time on that. You have a chain, and you can describe chain and reuse chain and compose your own chain. It's like doing a CI/CD pipeline at big scale, but for the request of your request router. Finally, you have the services where they are created automatically based on the labels of your system. So in that case, for example, traffic watch for Docker, and you have Docker Compose that scale to 2 instances. So you have a by default load balancer with 2 instances. If you've put the right label on this container, you can enable stickiness or canary or mirroring. And then you can compose the services, play with the headers. You can apply a lot of new features on that. You can say it is Kubernetes and here Docker. You can totally do that. So to summarize, you have your request that enters in traffic through an entry point that listen on a port basically. Then the routers will decide if it takes the request or not. If it takes it, it might apply some changes through middleware, and finally pass the request to services, which will take care of the load balancing. That's how traffic works. Okay for everyone? No question? Cool. Still not sleeping, almost. One last word about the configuration. The whole idea of traffic watching for dynamically your providers, we really, in that new version, try to put to the users the concept of static and dynamic configuration. Static configuration is listen to the port 553 and watch Docker engine on that TCP socket, or watch Kubernetes on that API server, or Mesos, or whatever. And here are your static certificate, and here is the let's encrypt Acme for whatever domain. That's all. And then dynamic is everything comes from the providers. You can even have certificates or TLS options that come from Kubernetes and services from Docker. You have a mix of those, and then traffic will mix everything here. That's the idea. How do you handle traffic? So today what I want to show you is that part. Because I lied when I said you don't have to write the configuration. You already knew that. Yes. So you don't have. The developer have to. That's better. So who is developer on the room now? Ha. Okay. It's a trap. So let's see a bit of configuration. So here is a simple example that I will show you the basic configuration. You have Docker engine. You have traffic listening to the Docker API of that Docker engine. So yeah, that's totally production ready, obviously. Yes, one server with one Docker. And then I start services that traffic have to watch and automatically load balance to. That's the context. Okay? The goal is just to show you the initial configuration. So this is the quick start on the documentation, so don't waste your time reading. So is there anyone here who is not at ease with Docker Compose syntax? Raise your hand. Okay. Are you at ease with Docker concepts? Yes? Okay, so Docker Compose is a command line that parses a YAML file. Yes. And that will take care of starting the container for you. And it helps you to maintain the order, so you can have precedency. It helps you to manage the container as services, so you can handle per services, you can scale them, and you can spawn a shell inside. It provides a lot of features like this one. You can have inheritance of files, you can have per environment. So it's a way of templating your command, what you used to do with whatever system, Chef, even a bash script, except it's on a YAML file, and it's built by Docker. So in that example, I define two services that I want to run. The first one is the reverse proxy, which is obviously traffic version 2, and a web application. So as the name implies, we are working at HTTP level here, okay? So for traffic, I command traffic to watch for Docker. So it's a one flag, or it could be a TOML file or a YAML file. I use command line because for me, I prefer it's easier for slides. We need traffic to be bound on the port 80 of the machine. that syntax means port 80 of the server is bound to the port 80 of the container traffic. Okay? That's all. And finally, this is the default port for HTTP, so traffic use this by default. Finally, that one, don't do that on production, please. Okay, please, please, please. I can explain that after during the pizza. It's just for the sake of saying traffic need to communicate with Docker. This is the way to communicate with Docker. This gives routes to traffic to your machine. Okay, so don't do this on production. Now the web application. So my developer told me continuous WAMI. Yeah, they are developers, so it's latest. They don't even have a version. No, I'm just joking. Don't do that in production. Never use latest. Never. Trust me. So I show you latest because that's the part. I'm not developer, not sysadmin. I can do whatever I want. And the configuration that you have to write. This is a label in the case of Docker. So in that example, I say traffic. I want you to create an HTTP router named web app, which rule for routing is every request that come with the host, you know, the header host or the host at the TCP level. When you do HTTP and host is empty. So let's say hosts. If it's localhost, you get all the requests, whatever path, whatever cookie, whatever headers. Everything will be by default sent to that application by traffic. So now what is the next step? There is no next step. Docker compose up, and with that example, you directly have your request that come to on the port 80 directly sent to web app. That's the most simple use case. If you scale this one, traffic will do by default round robin load balancing. If you want something else, you add labels here. So a bit more complex, but not that much. Let's say same server, I want to add a second web application. I want to add a Jenkins server. Yes, some people still run Jenkins. I'm sorry for that. So here I describe the new service. So my developers send me the definition of the service. They say we want Jenkins based on the LTS version. Okay, LTS, there is a tag. It's always the minor changes and security fix. No more latest. It's okay. And they say we used to access Jenkins on /Jenkins, so we configure the container to watch requests on /Jenkins, on the path /Jenkins. This is here. Jenkins is the IP of the container, port 8080, which is the default. This is the documentation of the image, /Jenkins because that option. So my developer told me to do that, and they already configured the option I need. So the first option, I told you that traffic watch dynamically for every event. On the previous, you don't have to configure the port here. Do you know what port is it? So yes, but it's a guess. We would have to check the metadatas, so the default expose port from the image continuous WMI, right? Or we have to explicitly set expose 80R. This is a metadata. In that case, you have to tell traffic to use 8080 for a simple reason, is because Jenkins exposes 2 ports. So how do we know which port to use? Traffic is smart, but not that smart. It cannot poke Jenkins saying, what is your HTTP port, buddy? I mean, it's not possible. So you have to explicitly say it. So what do we say? We say traffic, create an HTTP service named Jenkins, which load balancer system has a server port of 8080. Okay? And finally, secondly, we have the same router as before, except here, we want the request to come on mycompany.org and the path prefix /Jenkins. And finally, that one is the glue. It say, okay, the router name Jenkins is connected to the service Jenkins. That's how you link the system. Okay? So this one here looks weird because, I mean, there is one router, one service, we're not sure. That one exists only because you can have multiple entry points for a single container. So you have to wire everything correctly. So in that case, you start that system and every request coming on traffic on that host name with that prefix, so http mycompany.org /Jenkins, will be automatically redirected to http Jenkins 8080 Jenkins. No need to reload traffic for that. It will dynamically auto-configure itself. Okay? So same, you can even do rewrites. That's also a common use case. In that case, my application here is not able to handle request on slash whatever. It can only, as a backend, handle on slash. So in that case, no problem. Same routing rule. I say git server, my company, and pass slash git server. If the request meets this condition, then the router name git server will handle this. And then I associate a middleware. So the middleware, if you remember, the middleware transforms the request once it has been selected on a router. So what does the middleware is doing? It's a strip prefix. So every request intercepted by my router will, if they have the prefix slash git server, you remove that prefix from the URL and from the headers in case there is redirection. It's a rewrite. It's a simple rewrite. Then you can do more complex rewrite, of course, with big regex. And now you have another problem, but that's another story. And finally, one, it's because I love to brag about this one. I love Nginx, but if you ever have run a WebSocket application with Nginx, you are a bit sweaty because the amount of configuration is really complicated. So the performances are very good with Nginx, but the configuration overload, especially when you have to handle new hires that need to learn the configuration, it's really complicated. And this is how personally I went to Traffic. Because here, how do you deploy an application with Traffic? You just deploy it as any HTTP application and it just works. There is one reason for that. It's not because Traffic is better. It's because Traffic is 4 years old and Nginx is more than a decade old. So the settings in Nginx landed later on the core, while on Traffic it was already a thing. So it has been built on the source, on the core of the system. So that's why it's supported out of the box. But that's why I like that kind of tool, automatic, and I don't have anything to do with that. Okay? Okay, time for just a word with Kubernetes. Uh, Raise your hand if you are running or plan to run with Kubernetes. Or whatever system you have. And keep your hand raised if you really don't want to do that with Kubernetes, but it's mandatory. I see. So in Kubernetes, it's a powerful tool, but since it's powerful, it requires a big learning curve. So great power, great responsibility, blah, blah, blah. So use it if you need it. If you need it, it's powerful. If not, then you will have trouble managing that. You will shave yak all the time. So in Kubernetes, there is no concept of container, basically, very simplified. You have the concept of pod. A pod is an application. It's a container, in fact, to put that simply. So then you define concept of services, which is basically a load balancer, an internal load balancer between the pods. So in that case, I have two applications that have two replicas each. That's what the service and the pod means here. So traffic is what we call an ingress controller. So like there is a tons. These are the implementation of whatever tool to route requests from outside to the services. This is what an ingress controller is in Kubernetes in general, not only traffic. So the default de facto is Nginx, which work very well, and you can alternately use others. And one of the power of Kubernetes, it's complex, but you can install different ingress controller. I really love that kind of thing. It helps you to try differently, to do A/B testing even on your infrastructure pieces, or you can have an internal and an external ingress controller, or whatever scenario you could have. The ingress is a rule, a standard rule, written in YAML, which come from the Kubernetes project, which is really standard and really strict. And the ingress controller is responsible for implementing that rule. So if you say, I want the request on the host name blah 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 to go to the service name Toto, then this one, ingress controller, whatever it is, will take care of implementing. So it's really a nice fit for traffic because this is what we do outside Kubernetes already. So in that case, we really fit on the ecosystem here. So what does it look like? This is Kubernetes only. The only traffic specific thing is that line. If you don't put it, it will use the default ingress controller, so most of the time Nginx, or your cloud ingress controller. If you install traffic inside Kubernetes, you just add that label, and this will be taken care of by traffic. Okay? This is a standard ingress. However, I don't want to spend too much time on that. If you are interested, go and we can discuss about that. The new version will just have a minimalistic support of that for a lot of reasons. Mainly here, this will work. That's simple. But as soon as you want to configure your ingress controller, you require annotation. There are 80 annotation for traffic, 120 for Nginx, more than 200 for contour. HA proxy is next to 300. So basically you pass amount of configuration file in the form of annotation, so key and value, which is a multi-line YAML. So the initial premise of Kubernetes saying ingress controller can be swappable and universal, that premise has not been met with the ingress version 1. So now most of the ingress controller in the area, we started that with a contour, which is using Envoy, Kubernetes low-level proxy from Uber. And now everyone is going on that direction using custom resource definition. It's just a way to express new objects inside Kubernetes outside the standards one. It's an extension mechanism. So in our case, the kind ingress route, it's an object only for traffic. So in fact, I'm cheating. We are working with Contour, with some people with Envoy, with Glue, and now HA proxy, and we all have an ingress route. And our goal is to go to the next step and define the next step ingress v2 with this concept in mind. So we are right now in community discussion, challenging each other to find the right trade-off between what are the common features for everyone and what are the specific features that you need to extend to provide value as an ingress controller provider. So I pass on this example if you have question here. Time for the demo now, where I am on timing. Perfect, I'm on time. So that one for me was really a newcomer. I used to work with HA proxy years ago also. You are now able to route requests using TCP, not only HTTP. So until today, it was an edge router that you have to put on the outside. I will show you with version 2 a scenario where you use traffic to proxy request to the MongoDB. Obviously, that traffic instance is not mapped to the external world, right? It's a database, okay? But in that case, I want to show you what we can do with traffic. And then the rest is yours based on your use case. So, you decide one day to put traffic in front of MongoDB because why not? So how does it look like? You want to configure an entry point on the default port of MongoDB. You need a rules. You only have one kind of rules that exists. Since you are at TCP level, no host, no header. I mean, you don't know what will be the application protocol. The only thing you might have is the host ECNI. I will go on that one on the next demo. So in that case, I don't have any host ECNI, so the default syntax is a host ECNI all. It's a catch-all. So all requests on TCP layer that will come on that entry point will be forwarded to the corresponding service. Even if the protocol is not the same between client and server, we don't know. We are TCP, we just pass the request and the response. Okay? So, what does it looks like in terms of code? Can you read? So I'm still using the Docker Compose because it's globally quite simple, and I used the same before. So I have a traffic reverse proxy. I enable the provider Docker. That one is for the web UI, we don't care. And I declare to traffic, remember static configuration, I have to tell him watch this port. That's a simple one. So that port is obviously exposed outside, so that my Mac can reach the Docker engine through that port. And I communicate with Docker. Then I have a MongoDB database with the domain name mongo1.local. And I configure it the same way as I presented you with the HTTP. Traffic create a TCP router named Mongo, which rule is catch-all. Every request on that router will be forwarded to the corresponding service. which is the service that represents that container. Okay? And then I just connect the dots. I want the entry point Mongo to only send requests to that router. Because if I have another router for HTTP, my previous example, I don't want to mix everything. I want to restrict. So this is a restriction. Okay? So let's go. Docker compose up. So that command parse the file and start the containers for me. If I do docker ps, I have two containers running. Mongo, which is not exposing publicly any ports. It's only a private port inside the Docker network. And traffic. Okay? So now, let's connect. Where is my README? I have a cheat sheet. Because I'm not that at ease with Mongo. Okay, so I have a client binary Mongo, and I connect to the host mongo1.local that points to Docker engine on the port 27017. Okay? And I can connect to my database through traffic. And I can type the command as always, so I have three databases. So let's start the history with you have proxied as a sysadmin the MongoDB legacy database on production and database with an internal traffic that you use as a proxy for now. That's the most minimalistic. Let's go to the second demo. So you did the traffic stuff Monday, Tuesday. There is a security audit that passed on your platform and that say, hey, you must have encrypted connection between the Mongo clients, your application, and the database. Bad luck for you, the database administrator is on day off all the week. So you have to take care of that for the next day. How to do that? Let's use traffic. Traffic is able to terminate TLS for HTTP. It can do the same for TCP. So TLS is not happening at TCP layer, but the application protocol use TLS. And when you have a layer 7 application that use TLS and support what we call server name indication, the first packets, the first TCP packets, have that server name indication, which is a string, in clear before the other packets are encrypted. This happened during the TLS uncheck. Do you remember that one? Like, are you ready? I'm ready. Are you sure you're ready? I'm sure I'm ready. Okay, are you ready to encrypt? Time out. Are you ready? You see that part. During that part, you can catch the name, which is basically the host. But it's only on certain application protocol. It works with MongoDB. It doesn't work with SSH. So if your protocol does not support TLS with SNI, then it's catch-all as we did on the previous. It still works, but you have to allocate one port. So in that example, let's ask traffic to terminate TLS. We don't have encryption between traffic and MongoDB, but at least the client to the platform, that part will be encrypted by TLS. It's a first step, so you can say to the audit, okay, we are working on that. Here is a proof that we started to encrypt the connection. Okay? So let's do that with the demo. So what are the changes from previous Docker Compose? First, I pass a TOML file in that example. It could be a YAML file that say to traffic, hey, your certificates can be found here. Traffic will load all certificates. I could have used Let's Encrypt, but I don't know if the internet is working, so I want a working example. So I use certificate I generated myself. So you have your certificates and you point them to traffic. This is why I've mounted the certificate inside a container so traffic can access them. The rest is basically the same. I have the entry point and I will listen to Docker. The only add-on that my developer did is we want, from the platform point of view, TLS encryption enabled for that application specifically. I could add more options, like I only want these ciphers or I only want that certificate. You can tune that, but here, most simple example, I want TLS enabled. That's the only difference. Okay, no question? So So I started the 2 container. I still have 2 containers running. As you can bet, my demo is working. So let's go to that fact. I'm using, I'm using the same command as we did before, and it doesn't work anymore because I don't specify that I want to enable encryption. So the server traffic in that case just refuse the encryption. Okay? So okay, let's enable SSL, so dash SSL, and I provide the self-signed certificates because it's a local demo. In real life, you have real certificates or you have let's encrypt. Well, it's not working. What did I do wrong? Oh, yes, good catch. Thanks. Better. Okay, so now we have, thanks, all the work goes to traffic teams. I didn't do that. So that part is encrypted. So my last demo for today will be now the new database come back from days off and say, hey, we will have a new production instance with the latest version of MongoDB that takes care of TLS termination. So in that case, you can start thinking about end-to-end encryption. Encryption until traffic, and then traffic pass through. It does not decode the TLS, it just passes the packet as it to the right instance. However, here I challenge myself saying everyone is going through the same port, same couple IP port. Only the domain name change to illustrate the server name indication I just described. Okay? So all the requests come from the one, and since we support correctly SNI, we can route on one or the other based on the server name indication on TLS. So, down, no, down, 3. So the configuration is still the same for both traffic. I did not change traffic. I did not change Mongo 1. And the definition of the new instance is a Mongo 2 server where TLS is enabled with the option pass-through that say it's not the role of traffic to terminate TLS, it's the backend that will take care of that. And then I configure Mongo to pass it the certificate, as I did with traffic. Okay? So when it's Mongo 1, traffic terminates. When it's Mongo 2 terminates. Same IP and port. So let's start that service. I have now 3 containers running, traffic, Mongo 1, Mongo 2. Okay for everyone? So I still have the same command for connecting to Mongo 1. And to prove you that I'm not rooted on another instance, I will create a new database, okay? So let me just open the cheat sheet because I don't know the MongoDB commands by heart, obviously. It's a use. No, it's use. So I create a new database. I populate it with some data. So now I have a meetup database created on the production instance, Mongo 1, okay? So now I'm trying to connect. So Mongo 2 is also pointing to localhost in my case. So both domain names point to the same IP. I just changed the host name with the same option, same certificate for everyone. So first it works, yay! And now the proof that I'm not completely totally crazy is that this is the new instance. So in that case, we just enable the right TLS pass-through. So the developer or the person in charge of the backend service enabled that option. It's not me as traffic administrator, and everything went well. So I could show you the demo 4, but the smell of the pizza is telling me I'm out of time and I'm with you guys. So we could also mux HTTP through TCP if you have TLS enabled as well. So that one does not make any sense in real life. It's just for the fun. So let's pass on that, or I can show you after ordering the pizza. So this was the demo. So my goal here was to just give you an insight about what is traffic, what it does and doesn't. We have a lot of new features that I could spend times on that. We can do YAML. I mean, it's not enough YAML in Kubernetes. We can do that. Trust me, I hate TOML personally. I don't have my brain wired for TOML. So I'm really happy about YAML because for me, when I read it, it's clear. But some people prefer TOML. So instead of choosing, we bring the choice. UDP is there. We have advanced load balancing. You can combine all of those. So I let you play with Traffic V2. It's currently in release candidate. We expect the GA to be in 2 weeks. So unless we are late. If we are late, it will be released when it will be ready. But any feedback is welcome, especially on the documentation because we miss a lot of documentation still. We are working on that. Okay? More info, you have the link since you will have access to the slides. Just a quick word. I change my hat now. It's the I need to eat at the end of the month hat. That means we also sell products. Traffic is free. You can take it for free. You can do it whatever you want. If you have the special need where you require high availability, and by high availability, I mean you are not able to afford a fine-tuned load balancer in front of your infrastructure or a system that will restart your load balancer very quickly before the TCP retries are ended. If you are not able to afford that, then you might want to use Traffic Enterprise Edition, which is open source with high availability and distribution feature. The idea is simple. You have one instance of traffic that goes down, the other take the load. What does it bring? Additional security. I don't say security, I say additional security because we are split in two components. You have instances, one by default or free, we use Raft for that will handle the access to your Docker or Kubernetes API, and the other that will be dumb. They just receive configuration, so you can split responsibility and protect your credential. You don't want someone breaking out on your edge proxy to access your Docker API or whatever system. And this brings you scalability. Since you have dumb instances that are, by dumb I mean stateless, if you have a peak of traffic and you want to create new instances and then remove them for not paying for the resources, Traffic EE allows you to do that out of the box. So you can build it on your own with the open source version, but here if you are really willing to pay for that, and obviously the support 24/24. So to sum up, that's our Enterprise Edition product. That one targets 2% of the traffic user. So I don't know if you're interested or not. I will just forward you to the sales because I'm not on that part of the project. Okay? I remove my hat. Oh, by the way, it's free trial. So I still work for the documentation with the team. If you want to try it for free, feel free. Any feedback is welcome and it might be interesting. I never know. I told you about north-south and west-east traffic. Okay? So I want to present you Mesh, which is our new product released last week. So it's really out. What is Mesh? So it's for Kubernetes only. It's a service mesh that takes care of the routing of requests between your applications, like Istio, like Linkerd, like Consul Connect. Kubernetes only for now. The idea is the following. Standard Kubernetes, you have an ingress. It's traffic, pure random, and traffic routes to your application. And your application need to contact another application, like it's your home page and you need to contact a system for you have bought a computer, you might be interested on 1,000 computer more, in Amazon, for example. So you need to contact service to service. It's direct. How do you manage to trace the request when you have microservice grids? You need tracing, you need metrics, you need all these stuffs. You can build it already with Kubernetes Vanilla, no problem. You just have to learn and to do that step by step. What we want to bring is the same simplicity as Traffic bring. By saying you install Mesh, it automatically installs a tracing system, which is Jaeger or Zipkin, or you can connect to the existing one. It already installed the metrics system or connect to your already present one. And once it's installed, It's non-invasive. You can decide to send the traffic to the mesh, and you will benefit immediately of tracing and metrics. So if you use traffic as ingress, you can trace a request, and you can have all the information on the Jaeger dashboard because we control that on the mesh. You can see, okay, it spent this time here, it went there, but it should have been there, it spent that time here, and then the response that time, and you can trace the request and have all the metrics about that out of the box without having to even learn how to do that. That's what we want to bring with you. And so for the people that are inside this world, it's built on traffic. We use traffic instances. It's SCMI compliant, which is the W3C for service meshes. So you don't have to, it means swappable. And it's not only Kubernetes only. VMware has announced that that thing will be extended. So it will be multi-cloud, multi-provider, not only Kubernetes in the future. And we really hope to go on that road with them. And it's opt-in by default. That means you have to enable the mesh on each of your application. That means you can install mesh, it won't break your cluster. Because this is generally what happens when you do Linkerd or Istio. Those products are really powerful, but on organization, when you have plenty departments that need to coordinate themselves, for us, it was an issue. So here, it's the contrary. You install it, and we don't have a side container that intercept and change your traffic. You don't have to manage that. You can do opportunity per opportunity. That's how we see the service mesh from our point of view. So you have a link to the website if you want more information. It's currently in 0.1.0, so obviously not production ready yet. And that's all for me. We still have stickers, maybe? Next to the pizza, if you want some. Continuous is hiring, so it's a bit of evangelism here. Just in case, run that container and solve the enigma. Sorry? It's for people that like enigmas. Shameless ads. No remorse. So thank you. If you want the links in HTML, the source, everything is open. You have the QR code, and I will put the link also on the meetup group and send them to Karen. And PDF for offline reading if you take the plane, and HTML online either. So thank you very much. That's all for me.